All right, so go ahead, copy down 7, 8, and 9. Let me go ahead and put the exponent on 8 because that was wrong. Let me find my little pen now. And let's just copy down one at a time because I don't know how much space it's going to take. This is a 3. So we kind of talked about this yesterday. Pearson, we should be taking notes. So we kind of talked about this yesterday, or actually we did talk about it yesterday. In number 6, so when we're talking about variables, we're looking at groups. This is how many I have. This is how many are in the group. So essentially, this is like saying I have 10 people. I want to put them in groups of 5 because that's the number in my elbow. If I have 10 people and I want to put them in groups of 5, show me with your fingers how many groups I can make. 2. Would I have anybody left over? No. So it would simply be y squared. That would be my answer. Y squared. That's it. All right, go ahead and copy down number 8. Okay, so we have 3 different things under my radical. We have a number, we have x's, and we have y's. We're going to separate them down. Each one stands alone. So I'm going to start with the 125. So I have the cube root of 125. And then I have the cube root of x to the 6. And then I have the cube root of y to the 3rd. Bless you. So when we're talking about a 3, that's our perfect cubes. You can build a cake, all right? But I have some people who are not fans of the cake, which is fine because I'm not really either, but I like to teach different ways. What you can also do is just make a list of your perfect cubes. If there's a 3, let's make a list of our first 5 perfect cubes. So in your calculator, let's just find these. 2 to the 3rd, 3 to the 3rd. You may recognize what it is already, but go ahead and find these. I don't count 1. We don't use 1. 1 to the 3rd is 1. It doesn't matter how many times you multiply 1, it's going to be 1. All right, go ahead and find those 5 numbers real quick. See what you get. I don't know about the last one. So do you see that one of these gives us 125, right? What number do I multiply 3 times to get 125? 5. So that means that the cube root of 125 is just 5. Just 5. Going back to your variables, I have 6 people. I want to put them in groups of 3. How many groups can I make?
2.
Just 2, so that would be x squared. I have 3 people. I want to put them in groups of 3. How many groups can I make? 1. This would be your answer. So as we go along, the questions are just going to get more and more complicated, basically. All right, go ahead and try to do question 9 by yourself. I'm going to write it over here. So we have the 4th root, 12 apples, and the 4th root of 8 bananas. See what you get. All right, who agrees with my answer? So we got 3 groups and 2 groups. Any questions so far? All right, let's keep moving. All right, I'm going to, let's look at number 10. Go ahead and copy down 10. Now, what's the invisible number? When you don't see a number, there's a 2. So this means I'm looking for twins. I'm looking for pairs. So I have a to the power of 10. We're going to put that by itself. B by itself. And C by itself. And we're going to look at each one separately. So now we're talking about leftovers, okay? When we have leftovers, those are the terms that have to stay underneath the square root, okay? So for my first one, I don't have any leftovers. If I have 10 people and I put them in pairs, I'm going to have 5 pairs. No one's left out of a pair. So that means that this simplifies to just a to the power of 5. If I only have 1 person, I don't have enough to make a pair. So I'm just going to make a little square root. That 1b has to stay. Because if you don't have enough, it has to stay where it is. All right, if I have 9, I can make 4 pairs, but 1 will be left over. Okay? So I have c to the 4th, but then 1c is going to stay. So this would be my final answer. You are more than welcome to make 9 C's and circle the pairs and all of that. You can do it that way also. But this is my final answer. So now we're moving into terms where there will be things left under the radical. And Kenny, you can write your pass at any time and I'll sign it. All right, number 11. Let's look at number 11. Go ahead and copy this down. So you have a cube root. Now this is 4 terms, because remember, the negative is separate. So when I separate it, I'm separating the -1 from the 40. So we're going to break this apart to 4. 4 separate cube roots. So the index is 3. Who remembers from yesterday? When we have an odd index, and you may need to flip back in your notes to yesterday. When this number in the elbow is odd, do I leave it or do I take it out? Take it out. So anytime, and let's go back and review that. So if you have a radical and the number in the elbow is even, and it's a -1. If you pick up your calculator and you type up put in parentheses -1 to the power of 4. Everybody type that in. Pick up your calculator, type in parentheses -1 to the power of 4. Do you get -1? No. All right, put in an 8. Parentheses -1 to the power of 8. Do you get -1? You're never going to get -1 as long as this index is even, okay? But now let's do it with an odd number. Change the parentheses, keep the parentheses and change it to a 5. Do you get -1? Yes. So whenever the index is odd, we can actually get the negative so it can come out. But it's impossible to get -1 if you raise -1 to an even power. So when the index is even, we leave it. We leave it right there. It cannot come out because essentially it's imaginary. But we're not putting it. We're just going to leave it because we're not solving it. So if anytime this is even, this is not real. We can't. It's impossible to reach. So in this case, we have an odd index. And because it is odd, it can come out. And when it comes out, it's just going to become a regular -1 because it can come out. All right, so let's revisit our perfect cubes again. So 2 to the power of 3 is what? 8. 3 to the power of 3 is 27. All right, I'm not going to keep going. I'm looking for a perfect cube that will divide into 40. Will any of these numbers divide evenly into 40? Try it. Take 40 divided by 8. See if you get a whole number. And if you do 40 divided by 27, it's a decimal. So this is the perfect cube that I'm taking out. So what I'm going to do is I'm going to separate this to the cube root of 8. And then 8 times what is 40? What do you multiply by 8 to get 40? So I'm going to separate that to the cube root of 8 times the cube root of 5. Okay. So far, we have that cube root of 8, which is going to change to a 2. And I have this. This is going to stay. We can't do anything with that. All right, now let's talk about 14. And if you want to make 14 x's, you can. I'm not doing that, but you can. No judgment. And then circle groups of 3. I'm sorry, what'd you say? Because the cube root of 8 is 2.
Okay.
Yeah. So if you have 14 people, show me with your fingers how many groups you can make with 14. How many groups of 3 you can make with 14 people? How many groups of 3 can you make with 14 people? 4, right? So I have x to the 4th because I have 4 groups. But then how many people do I have left out that can't be in a group? 2. They have to stay. All right, lastly, I have 10 people. Show me with your fingers how many groups of 3 can I make with 10 people? How many groups of 3 can I make? You can make 3. So this would be y to the power of 3. And then how many y's will be left out? Just 1, and that has to stay. Okay, so now we're ready to clean this all up. So in front of the radical is everything that's on the outside. So on the outside, I was able to take out a -1 times 2. And what's -1 times 2? So I have a -2. Now I'm building my answer. Keep forgetting to switch back. So I have my answer. So at the beginning of my answer, I have a -2. How many x's? How many groups did I have? 4. How many groups did I have for my y's? 3. Now I'm going to make my radical in the back. And in the radical, I'm putting everything that I have highlighted. So that's a 5. That's 2 x's. And that is a y. This would be the final answer. So you have to take it step by step. Yes, Sasha.
Since you did the cube root of 8, how would I know not to do the cube root of 5?
You can't do the cube root of 5. So when you look at these numbers, these are my perfect cubes. Will any of these numbers divide into 5? Evenly, though. Yeah. Now, I'm gonna do this one time. You can make a cake. All right, so if you were to make a cake with the 40, and again, if you are a cake person, you just have to make your cake on the side. There's nothing wrong with it. But if you want to make the cake with the 40, you would start off by dividing it by 2. Then you would get to a 5, and we have to divide it by 5. So I'm looking for a group of 3. What do I have 3 ofs? 3 2s. What didn't I have 3 of? 5. It had to stay. There is nothing wrong with making a cake. You can make a cake. Absolutely. All right. Let's keep moving, y'all. So now we're going to look at some fraction exponents. Let's look at these real quick. So who remembers the rule when you multiply with the same base, you're multiplying. What do we do with our exponents? Do we add them, multiply them, subtract them, divide them? What does that rule say? So let me go back. Let's just pretend that these weren't fractions. Okay, let's just pretend that this was x squared times x to the 5th. What would you do with your exponents? Would you add them and get 7? Would you multiply them and say that they're 10? What would you do with those exponents? Multiply them, not multiply them. You would add them. X to the power of 2 plus 5 means I have x to the 7th. We're going to do the same thing, except now they're fractions, but that's okay. So I'm going to take x to the power of 2/3 plus 5/3. So 2/3 plus 5/3 would be what? What do you have to have in order to add fractions? A common what? Do we have a common denominator? So what would it be? 7/3. All right, so now going back to our power rule, let's write this in radical form. Remember, the denominator is in the elbow. So if I were to write this, it would be a 3 would go here, x to the 7th would go here. Now simplify that. How many groups of 3 can you make with 7 people? So go ahead. First you write it. First you have to add the fractions. Then you rewrite it and then you simplify it. So we have 7 people. How many groups of 3? 2. So I have x squared, but I have some left over, right? How many are left over that I have to keep underneath? 1. This would be the answer that I'm looking for. All right, number 13. Now it's a little bit more stuff happening. So we're going to start off by adding the numerator. Add these fractions together. We already have our common denominator. I made it easy. Everything has a common denominator. So what is 3/4 plus 7/4? 10/4, yeah. All right, now, who remembers what do I do with my exponents when I'm dividing them? Subtract them, good. So what we have is b to the power of 10/4 minus 1/4. Which is b to the power of 9/4. All right, write that in radical form and then simplify it. Write it in radical form.
Did you say plus that?
No, this is subtraction because it's division. When you divide, like when you have a fraction, that's when you subtract the powers. So here, this is subtract. So here we subtract it. And we started off by adding. So go ahead, write that in radical form. What number goes in the elbow? The 4 or the 9? The 4. And you have 9 bananas. So you're trying to make groups of 4 with 9 bananas. So that's going to give you, show me with your fingers, how many groups can you make? Any left over? How many? 1. Now don't forget, this is very common because we're not used to putting a number in the elbow, but always put that number back in the elbow unless it's 2. 2 is the only one that doesn't have to be written. But if there's any other number in the elbow, we have to remember to put that. That would just be minus half a point. Always carry over the index. It has to be written unless it's 2. All right, we're almost finished. Let's do a few more and then we will call it a day. Appendix 10, we are actually almost done with it, which is good. So we'll just plan on doing, today is, yeah. So let's just do 1 and 2. I'm just going to do a quick review. So copy down, we'll just do 1 at a time. So go ahead and copy down question 1. So So we're just doing operations with radicals now. You've seen these before in algebra, but I know for some of you all that was 2 years ago. So now we're multiplying. Let's talk about multiplying. All right, when you multiply, they don't have to be like terms. Okay, multiplying, they don't need to be like terms. All we're going to do, multiply the numbers, multiply our radicals. So if I take 5 times -3, I get -15. If I take 8 times 3, I get 24. But we're not done. So I'm going to pause right here, and I want you all, because we should be getting a little bit better with this at this point, I want you to simplify 24. You can make a cake. You can look, now what is this? These are perfect squares. You can make a cake. You can look for the perfect square. You can do it whichever way you want to. But I want everyone to simplify this 24. There is a pair of factors that can come out of 24. And you have to show your work when you do that. Friday. So yeah, I'm trying to finish all the teaching by Monday so that you'll have 2 days to practice. Thursday. I am going to cut some of the homework though. I will send a message out in Canvas during my prep today with the new. I want to shorten it because I do want you to focus on the test when you get the study guide. All right, let me see what we came up with. How did you simplify it? So you got to show how you got that though. You got to show me how. If you only have the answer, that's not enough. So feel free to build a cake. The perfect squares are 4. I always forget to switch that back. 4, 9, 16, 25. Okay, that's as far as we need to go. One of those numbers will go into 24. Which one of those numbers divides into 24? 4 times what? So I'm actually separating this to 4 times 6. This is what I'm looking for because I am aware that the yellow calculators will give you the answer. However, which is why some teachers don't let you use them. However, if I don't see this step, you're not going to get credit. So you need to show me how this changed to a -30. And if you can explain to me why the -15 changed to a -30, then you're not going to get full credit. I'll give you half credit because you did this part, but this part you don't get credit for.
Changes to -30?
Yes, and the reason why it does is because the square root of 4 is what? That changed to a 2. The 6 had to stay. And when you multiply those, you get -30 square root of 6. And that would be your final answer. All right, I'm going to stop there, but I do want you to copy down number 2. And then tomorrow we'll pick up here.